Alright, so trigonometry. It's basically, if you have a triangle, it's finding the angles and finding the sides. That's really all trigonometry is. Notice it almost has the word triangle in it. That's why they call it trig, triangle. Pythagorean theorem, that should be reviewed. That's one of the first things they taught you in 8th grade. It says that if you have two legs and a hypotenuse, you square the legs and add them, and that equals the hypotenuse squared. But this only works in right triangles. So that's why further in the unit, I'm going to teach you other ways to solve triangles, because not every triangle is right. And by right, I mean 90 degrees. So it works in right triangles. Now there's something called trig ratios, triangle ratios, and basically it's a proportion that relates the sides to its angles. For example, we have the trig ratio, or trig function, sine, cosine, and tangent. So let's say this is a right triangle. Kind of hard to see that. Maybe a different color will be better. So that's when they put a box there. Still can't see that. I'll try yellow. I try. But if you put a box there, that means it's 90 degrees. That means it's a right triangle. And we can use these trig ratios. Now we have what we call and this is our reference angle. Sometimes it's here, sometimes it's here. So you have to pay attention to that. But if the reference angle is here, and that's the symbol, I'm just not really good at drawing it, then we always call this, across for 90 degrees, we always call that the hypotenuse. And I usually just abbreviate that for hypotenuse. That is always the hypotenuse. But then we have two different words, and one is opposite and one's adjacent. And those depend on your reference angle. Well, if this is your reference angle, then this is opposite. If this is your reference angle, then this is opposite. Does that make sense? And very rarely will you see them use this 90 degrees. So if this is our reference angle, that means that over here is opposite. And then the other one would be adjacent. And the word adjacent just means next to. It's the side that's next to that angle that's not the hypotenuse. Okay, abbreviations. I usually just use H for hypotenuse. You could probably guess I use O for opposite. And I use A for adjacent. So now this word comes to mind, and that is I have this memorized. It's SOHCAHTOA. SOHCAHTOA. Some old horse caught another horse taking oats away. I just memorized SOHCAHTOA. And there's songs, I don't have those ready, but you could go to YouTube and just type in SOHCAHTOA songs and play a song, and it'll help you memorize this. way of memorizing. And all it says is S is for sine, C is for cosine, T is for tangent. And if you have the sine function, that's opposite over hypotenuse. And if you have the cosine function, that's adjacent over hypotenuse. And if you have the tangent function, that's O over opposite over adjacent. So sine is, you could put opposite over hypotenuse. So if this is your reference angle, then you would say sine of whatever that angle is, say it's 30, we don't know for sure, sine of 30 equals whatever this side is divided by this side. And that creates an equation that helps us solve for a missing side or angle. Cosine is A over H. That would be adjacent over hypotenuse. So what that means is if you know the adjacent and you know the hypotenuse, you could find the angle. Or if you know the angle and the adjacent, you could find the hypotenuse. Or if you know the angle and hypotenuse, you could find the adjacent. So if you know two of the three, you could find the third. And then tangent, that's the only one that doesn't have to deal with hypotenuse. And that is opposite over adjacent. Now, just like most functions in math, they have something called the inverse function, which is the opposite pretty much. So cosecant is the inverse of sine. And all that means is you do hypotenuse over opposite instead. So it's the inverse of sine. Notice S and sine. That's how I remember it. So if I see CSC, that stands for cosecant. Now secant is the inverse of cosine. And this is adjacent over hypotenuse, so this is going to be hypotenuse over adjacent. And I just memorized that there's a C here and a C here. I always get cosecant and secant confused because I see secant and I think, oh, that's the inverse of sine. But it's not. It's the inverse of cosine. Okay? So if it helps, I guess you could ignore the first letter and just go to the second and go, okay, that's an S, that's for sine. For secant, ignore the first letter. Well, there's no E, so you say C is for cosine, I suppose. Or you could just memorize it. And then cotangent would be the inverse of tan. So adjacent over opposite. Now all I want you to do today is to be able to set up ratios. And then tomorrow, after they're set up, you're going to solve. But today we're just going to set up the problems. Real fast, Pythagorean theorem. These shouldn't take you any. But these shouldn't take you any time at all. And in fact, I don't remember what this one is, but if you have legs that are 3 and 4, it's always 5. That's called a Pythagorean triple, and I just have that memorized. And 12, 15, I can't remember what that one is, maybe 13? But there's a whole list, and they're called Pythagorean triples that you can memorize. But all this says is a squared plus b squared is c squared. Well, this is a, that's b, and there you go, that's your c. A squared plus b squared is c squared. If this is the right triangle. This does not work if it's not a right triangle. So a is 3, b is 4, and we don't know c, so we'll keep that c. Now, common questions I've gotten over the years is, I know hypotenuse is always c, but how do I know which one's a and which one's b? And it does not matter. We could have made that a and that b, and it would not matter, but this is always c. 3 squared is 9, 4 squared is 16, 9 plus 16 is 25. Take the square root of both sides. And because we're talking about shapes, we're going to ignore the negative 5 and just say that c equals 5. Okay, so the hypotenuse is 5. The long side here is 5. So if you have 2 legs and you're trying hypotenuse, that's the procedure. Now here, again, this is going to be c. They let that be a, we're going to let that be b. Formula is still b squared is c squared. We don't know a. B is 12. C is 15. Now 12 squared, 12 times 12 is 144. And then 15 squared, 15 times 15 is 225. We are trying to isolate the variable I on one side, so that's minus 144 from both sides. Notice we did not do that over there. We get a squared. 225 minus 144 is 81. Take the square root, and you get a is 9. Now, if you don't get a whole number, then I would carry it out 2 decimal places. Okay? So a is 9. So that's the Pythagorean triple. If you have 12, the other one's 9. If you have 9 and 12, the other one's 15. I always forget that one. So anyway, we're not going to spend forever on that. That's review. Now there's something called special triangles. And those are when you have 30, 60, 90, 45, 45, 90. And yeah, we could do that. So, special triangles, if this is, and I need a better color, if this is 45 degrees, can you guys see that? I need to make that lighter next year. And this is 45, and this is 90. Then there are special properties. One is, if this is 2, then this is also 2. If that's 3, then that's also 3. If that's 4, then that's also 4. If that's 5, then that's also 5. The legs are always the same, partly because the angle that shoots out is the side it creates is going to be the same. And the hypotenuse, so it's going to always follow the ratio. These are the same, 1, 1. And then this would have 2. So this could be 1, 1, square root of 2, 2, 2, 2 square root of 2, 3, 3, 3 square root of 2, 4, 4, 4 square root of 2. It always follows that ratio. Now there's also something called a 30, 60, 90. for you to see. So if this is 30, and that's 90, and that's 60, and you can't really see that, but put down 60, then it follows these ratios. And it follows the ratio 1, 2, square root of 3. Or it could be 2, 4, 2 square root of 3. Or 3, 6. Basic one I always have memorized is the hypotenuse is always double the one across from 30. So if this is 6, then that's 12. If that's, then that's 40. So the one that's across from 30 is always half the hypotenuse. Whereas in a 45, 45, 90, the only one I really have memorized is that the legs are the same. So we may practice that. We may not. But let's go through all the special right triangles. So if this is 45, and this is 45, and this is 90, I'm just copying the one on top, we can find our trig ratios. One, let's start off with the sine of 45. Now sine, S-O-H. Sine is opposite over hypotenuse. So if this is my angle, and that means this is my H, this is my opposite, and this is my adjacent. And I'm going to start using H's and O's and A's, so I don't have to write them all out every time. So sine of 45 is O over H. So, S-O-H. So O is 1, and H is square root of 2. Does that make sense? Cosine of 45 Ka is A over H. Well, A is 1, H is square root of 2. And then tan of 45, tangent. By the way, please don't call that sin. That's just one of my annoyances. That's sine. Just to abbreviate, only write down the first 3 letters. It's not a sin. So tan is over, so, ka, toa, and that's O over A. 1 over 1, which is just 1. Now, I don't know what you remember from AG3, but there's something called rationalizing the denominator. You don't like square root in the denominator, which is not okay. So you multiply by square root of 2 over square root of 2, and this changes to square root of 2 over 2. Same thing. 1 over square root of 2 is the same thing as square root of 2 over 2. Same thing here. You'll never see a square root in the denominator on an ACT question. It's always rationalized. All right, so and then we could go through and we could do our inverse functions, but I'm not going to. Now, I wish this triangle was pushed over. Let's say this is 30. This is 90. And that's 60. And I'm just going to keep the same. This is square root of 3. This is 1. And that's 2. Oh, by the way, so pretty much now, if someone says, hey, what's the sine of 45? You could just say square root of 2 over 2. If someone says, what's the cosine of 45? Square root of 2 over 2. And by the way, I do need to show you this. Your calculator, it could do sines and cosines and tangents, but it spits out decimals. One, there's something called degrees and there's something called radians. And if you go to mode, notice right now radians is selected. We're talking about degrees. So if you go to mode and you're talking about degrees, you need to go change it to degrees by hitting enter over there. If you're talking about radians, then you need to change it over to radians. And radians, a key to that is when you start seeing pies. Pies are radians. Okay, so that's something important. So we need ours to be in degree. Remember, I did mode, and I changed that to degree. And notice when I type in sine of 45, I get 0.707, which is square root of 2 over 2. You'll never see 0.707 unless they have it round. Cosine of 45 is also 0.707. And tan of 45 is 1. Okay? So if you're on taking an ACT test, you can just memorize the tangent of 45 is always 1. Next. Let's do the ratios over here. Sine of 45. Oh, by the way, it's not hard, but the inverse of sine is what? Inverse of sine is cosecant, right? So your answer would be square root of 2 over 1. Right? Same thing here. The inverse of cosine is secant. So if you ask for the secant of 45, that would be h over a, which would be square root of 2 over 1, which is square root of 2. And if they ask for cotangent, that would be a over instead, which would be 1 over 1, which is still 1. All right, let's do these. Sine of 30. So I'm actually going to use both triangles. So if this is my reference angle, then this is my H, this is my O, and that's my A, because that's opposite my reference angle. Sine of 30 is SOH 1 over 2. Right? O over H. I should have put O over H. Cosine of 30. Well, cosine is A over H. And A is square root of 3. H is 2. We don't need to change it because square root's in the numerator, not in the denominator, so we're happy. And then the tangent of 30 TOA is O over A. So if this is my reference angle, opposite would be 1. So it would be 1 over square root of 3, which you can change to square root of 3 over 3. That's the same thing. So if you have 1 over square root of 2, that's the same thing as square root of 2 over 2. If you have 1 over square root of 3, that's the same thing as square root of 3 over 3. Okay? And then if we did sine, cosine, and tangent of 60, if I use that as my reference angle, well, this is still H, but now this, and that's my A. So notice A and O depends on the angle you're talking about. So sine of 60 is O over H. I'm using this one. Be square root of 3 over 2. Cosine of 60. Cosine, C-O-H. No. So, sorry, I said the wrong thing. C-A-H. And A is 1, H is 2. So if I type cosine of 60 in my calculator, it spit out 0.5. And then tangent of 60 is TOA. And O is square root of 3 over 1, which is just square root of 3. And the inverse of sine would be 2 over square root of 3. The inverse of cosine would be 2 over 1. And the inverse of tan would be 1 over square root of 3. And then you rationalize it. Am I making any sense here? So what I was talking about earlier was and I'm actually, this is going to be your homework. I'm actually okay with you using decimals to 3 decimal places. So like sine of 45, sine